So let's look at this number 4. So an astronaut on the surface of Mars measures the frequency of oscillation of a simple pendulum consisting of a ball on the end of a string. And on the Mars, the astronaut measures the time period of the pendulum to be 1.5 seconds, and also given the acceleration due to gravity on Mars is 0.38 times the acceleration due to gravity on Earth. So later during a journey to another planet, the astronaut finds that his simple pendulum oscillates at 0.92 seconds. So on an unknown planet, the time period is 0.92 seconds. So we want to find which planet is that. Okay. So we can first find the length of this simple pendulum. So we have the time period is given by 2 pi L over G. So we can find L by taking square on both sides, 4 pi squared L over G. So L is T squared times G on Mars over 4 pi squared. So T squared is 1.5 seconds squared. G on Mars is 0.38 times 9.8 meters per second squared over 4 pi squared. So let's find what that value is. So that's 1.5 squared times 0.38 times 9.8, that divided by 4 pi squared. So that gives me 0.212 meters. So that's the length of the pendulum, and the length doesn't change. So now we can find, using the same formula, we can find G of the unknown planet, and through that G value of G we can determine which planet is that. So G would be 4 pi squared times L over T squared. So 4 pi squared, length is 0.212, and the time period is 0.92 seconds squared. So let's see what that is. 9.89 meter per second squared, and this is close to the acceleration due to gravity of Earth. Okay. So that means the astronaut is on the surface of the Earth. That's number 5. So a 300-gram mass on 30 centimeter long string oscillates as a pendulum. So we have a pendulum, and this pendulum swings to some maximum height. So that's the maximum height that it swings. So we want to find the maximum angle that the pendulum reaches. Okay, so this is the maximum angle. So we can actually find this height, okay, this distance, and then we know this distance. So using trigonometry we can find this angle. So we know this whole length of the string. So to find this distance, so in order to find this distance, we can find this, the height, okay, height through which the pendulum rises. So we consider this to be 0 level. Okay. So y equals 0. So this height would be y. So we can find that by using energy consideration. So let's say this is 0.1 and that's 0.2. We know mechanical energy at 0.1 equals mechanical energy at 0.2. So mechanical energy at 0.1 is kinetic energy at 1 plus potential energy at 1. And mechanical energy at 2 is kinetic energy at 2 plus potential energy at 2. But at 0.1, it's the 0 level. That's what we considered, y equals 0. So potential energy would be 0. And at 0.2 is the highest point, so kinetic energy would be 0. And all the energy would be potential energy. So kinetic energy at 0.1 is 1/2 mv at 1 squared. Potential energy is mg and that height y. Okay. So mass and mass cancel. So we want to find y. So y would be v1 squared over 2g. So v1 at 0.1 is given, so that's 0.25 meters per second squared over 2 times g is 9.8 meters per second squared. So let's find that. So that gives me 0.00318 meters. So that's this y. Now to find this distance from top to this point, we can, so let's call that p, okay, that distance. So p would be this length of the pendulum minus this distance y. So length of the pendulum is 30 centimeters, so 0.30 meters, minus y is 0.00318. So p would be then 0.2968 meters. Okay, so consider this triangle. In this triangle, we can take the ratio of adjacent over hypotenuse. So adjacent over hypotenuse is cosine. So cosine is adjacent over hypotenuse. So adjacent here is that 0.2968. And hypotenuse is the length, which is 0.30 meters. So then theta would be cosine inverse of 0.2968 over 0.30. So let's find that. So that's 8.36 degrees. Okay, so that's the maximum angle of this pendulum.